Hey, my name is Kevin from Iron City Engineering, and today we're going to go over a problem for the PE or the FE that involves the behavior of concrete cylinders and compression. So we're going to start with a little illustration to describe what we're dealing with here. Alright, so this is our concrete cylinder. You'll see these pretty frequently on construction sites. Whenever concrete is poured, they take a certain number of specimens that they run tests on to ensure that the concrete is strong enough to sustain the structure and avoid structural failure. So essentially what we want to do in this problem is see how much weight we can add in compression before the structure fails. So that's basically the premise of this problem. So let's go ahead and get started. So a concrete cylinder has a volume of 1,357.2 cubic inches. If the ultimate stress of the specimen is 4 ksi with a factor of safety of 2, what is the maximum loading kips that can safely be applied to the specimen, ignoring the self-weight of the concrete? Assume the height of the specimen is 12 inches. Alright, so we're going to need a few formulas here. So formulas. So first is going to be the volume of a cylinder. Now let's try to clean that up a little bit. And that's going to be pi d squared h over 4. And then the cross-sectional area, pretty straightforward, it's pi r squared. And then the allowable stress is going to equal the ultimate stress. I'll try to fix up the handwriting there a little bit. Divided by the factor of safety. And then the last formula we need is the stress equals the applied load divided by the cross-sectional area. So we're going to start with the volume of the cylinder. Let's do a little break here. So volume of the cylinder is 1,357.2 cubic inches. And that is going to equal pi d squared. We know from up here that the height of the specimen is 12 inches. And all that is going to be divided by 4. So you come up with d equals 12 inches. And r, which is the radius, equals 6 inches. Alright, so let's go ahead and get our area real quick. That's going to be pi r squared equals pi 6 squared. And I'm going to have to punch that in the calculator. That's going to equal 113.1 inches squared. Alright. So now we're going to find the allowable stress. So there's that, there's that, there's that. So stress allowable, what we can see from up here, is the ultimate stress divided by the factor of safety. So from the problem statement, we can see that the ultimate stress is 4 ksi, and the factor of safety is 2. So that's going to be 4 KSI, which is 4,000 PSI, divided by 2 equals 2,000 PSI. So that's essentially the maximum allowable stress that we're allowed to work with. Okay? So we're going to move on to our final step, which is finding the maximum load that can be applied to the specimen without it failing. So the allowable stress is 2,000 PSI equals P, which is our applied load, divided by cross-sectional area, which is 113.1. Now we're going to solve for P, and I'm going to use my calculator for that. So I'm going to get 226,195 pounds. However, the problem statement asked for it in kips, so we would essentially divide it by 1,000. So that is going to equal 226 kips, and hopefully that's one of the answer choices. Let's scroll up and see, and yes it is. The answer is A. And the answer is A. So that's our final answer. Hope this video helped, and leave any comments if you have any questions. Hit the subscribe button, the like button, share with your friends, and I greatly appreciate it. Alright, see you next time. Bye.